Give me 1 second. So let us start up. In the meantime, I'm just sending you the code. Just give me 1 second. So guys, this is a link to the code that I will be kind of using to kind of showcase you guys that okay, how you can kind of build up a ICMP sniffer and injector. And basically, this will be a way by which we will be implementing an ICMP tunneling attack. Similar way how attacker would kind of utilize that to kind of evade detection in our organization. Okay, so the theme is that using because these this kind of packets like the ICMP packets, no one kind of analyze. It's quite like it's quite normal in an organization. Like there are a lot of noise. It's very difficult to kind of uh, let's say detect that okay the ICMP packets going back and forth between my organization and the external servers are indeed malicious or not. Okay, so it's very difficult to kind of detect those kind of attacks. So this is why we picked up the ICMP because in an organization, if we there will be a lot of people who will be kind of pinging the servers to see like if it is like on or not. Okay, so we'll see a lot of traffic like that. Okay, so that's the reason why we will kind of like an attacker will actually kind of utilize this ICMP tunneling attack to let's say send the message in and out from the company organization. Okay, because it will be really hard for them to kind of because they know that it will be really hard for the SOC team to detect this kind of attacks. Okay, so we'll try to kind of go to this quickly. So we have our MX host fired up. So let me quickly go to that. So what we do is that we do Python. Okay. We do Scapy. So let it run out. And in the meantime, what I will do is I will start Firefox. So Firefox is running, and right now it doesn't have any kind of packets. So what we do is so now what we'll do is that we will try to kind of make a ICMP packet. Okay. So the thing is that let me just quickly go over here, and what I will do is that let's say I ping google.com for example. Okay, I ping it, and if you see that okay, quickly we had a lot of packets over here. Like we had let's say the DNS query, and from there we got the IP address of the DNS, IP address of the Google, and that's what ping command is doing. And then that ping command is kind of responding to that Google servers, for example. Okay, Google server, for example. Let's say from here, what they're doing is my system is this is the ICMP packet, And if you see over here, it has a field called data, which is a 48 bytes, right? 48 bytes. And here the thing is that the ping command is actually injecting random text, okay, over here. And how that ping command is able to figure out that it has actually received the response that it has kind of sent out is because once this random data has been sent out, if you see the next packet that came from the Google server, it has the same text in this one, okay? So the random text that was sent to the Google server sent out that random text back to us, okay? So this is actually what how the ping command works. That is how the ping software is able to figure out that the ping request that went to the Google server, it is the same thing that ping the Google server replied, and that's how it is able to figure out okay, that the Google server is turned on, like it's on and accessible over the internet. Okay, so this is how the ping actually the ICMP thing actually works. Another thing is that this data, if you recall, this data is something in our control. We can kind of fulfill, we can kind of put any kind of data that we want over here. And what we can do is that, let's say we have a confidential doc file, okay, Word file, okay. So what we can do is that we can split that Word file in, let's say, 48 bytes, for an example, 48 bytes. And what we can do is that, let's say this is the system which we have kind of attacker has kind of got a hold of, like the Remix host or the Windows host. And let's say this is the malware writer C2 server, for an example, C2 server of the malware writer. Okay, so what can be done is that the attacker would kind of what they will do is that they will split the doc file, the Word file, in 48 bytes, let's say, for an example, and then they will add that data on this ICMP packet, and they will just send out the ping request as much as possible. And when the C2 server, the malware C2 server will receive those packets, what they will do is that they will read this data from this ICMP packet, and they will combine all those chunks together, and they will they will get the Word file at their end. So they will be able to kind of expel the doc file, the Word file, from the organism without getting detected by any other systems or any other kind of device. Okay. So this is quite tough to detect, and let's see how we can kind of implement the same thing which attacker would do. Okay, so what we do is that we again continue with our saving. There is no packets, and what we do now is that we will create that ICMP packet from ourselves. Okay, so so let's do something. So what we'll do is let me just go 1 second. So we'll use the same IP address of the Google. Okay. So what we will do is first we'll create the IP header, the same thing that we did yesterday. Okay, if you remember. So what we'll do is we will say, let's say IPP, the IP packet is equal to the IP header, and this in this will give the destination of the let's say of our C2 mail C2 IP address. Let's say if I'm an attacker, I'll give my IP address. So for now, just for testing, I'm giving the, let's say, the Google IP address, for example, 193.106. Okay. And if I go to the IP packet, we can kind of see that thing happening, right? So if I do a little bit more details, so you will get all the details. Okay, source is my Remix host, and this is the destination where I want that IP packet to go out. Okay. Now the next thing what we'll do is that we will be adding the ICMP header. Okay, ICMP header, and we will just say ICMP, and this is all we need to do. Okay, so we'll just see that how this thing look like. So, and we see that okay, it has all the things that we need. So it is an echo request because this is something what is going out from the organization. Okay, so we are kind of sending this ICMP request. So that's why it's tapping